Hello and welcome to Tech-decoded. I'm Henry Gabb, editor of the Parallel Universe, Intel's quarterly magazine for software innovation. Today I'm here with Sanjeev Shah to talk about software analysis tools for code modernization. Sanjeev is a vice president in the Core and Visual Computing Group and general manager of technical enterprise and cloud computing. His organization produces software analysis tools and parallel runtime libraries. Sanjeev is a founding member of the OpenMP Architecture Review Board and continues to serve on its board of directors. He has a bachelor's and master's degree in computer science and engineering from the University of Michigan and holds 16 patents in the area of parallel computing. Welcome, Sanjeev.
Thank you, Henry. Well, happy to be here.
Software development has become more and more complex and it's constantly changing. What are some of the biggest challenges facing developers right now?
People get software from all kinds of places these days. There's a lot of open source software they integrate. So just understanding all the software that they're putting together in their packages and so on is complex. In addition to that, architectures are evolving significantly. A lot of people, want access to their tools, to their applications and so on everywhere. They run them everywhere, all over the cloud, etc. Understanding just exactly what is happening in your application on a complex architecture with a lot of heterogeneity and so on has become quite challenging for people.
And so you lead the team that produces Intel Parallel Studio, essentially our flagship product for code modernization and software analysis. Describe some of the tools in this suite, because it's a fairly comprehensive tool suite, and how these different components help developers.
Sure. So Parallel Studio, it's a software development package. Fundamentally, it supports programming languages, different parallel programming models, analysis tools to help people analyze what's happening in their application and what's happening on the architecture that they're running on. In addition to that, we offer prepackaged math libraries and domain-specific libraries, which really try to capture the expertise that our engineers build into libraries so that people can use them really, really easily. So what Parallel Studio is really trying to do is empower developers so that they can focus on their work, which a lot of the time is doing science or enterprise or business or whatever that they work on, while using Intel systems very, very efficiently. We target two kinds of users. We target what we call domain specialists who really would rather focus on their domain, and we want to give them a lot of expertise that is wrapped in to libraries and tools so they can focus there and spend as little time on the computer science as possible. And then we also focus on what we call tuning experts. These guys really want to really understand their programs and want to get the maximum performance they can out of the architecture. So trying to help bridge that gap between the architecture and the software.
What programming languages are supported?
So Fortran remains the fundamental workhorse of HPC. It has been for a long time, and it continues to be used quite heavily. In addition, C and C++ have emerged in the last 20 years as really the foundations of any large-scale software development. They're being used very heavily in HPC and in enterprise and in cloud and so on today. In addition to those, we've recently added support for Python. Python is the #1 language, the fastest growing language. It has risen to #1 use worldwide. It's used for a lot of different things. They use Python for just gluing different pieces of software together. It also has very wide use in the data analytics community, in data science, and various data-related fields like that. What we found is the stock Python products are leaving a lot of performance on the table. So what we were able to do is take Python and plumb our really expert-created libraries so that you automatically get the performance out of our platform. And it's quite common to see very, very large performance gains, 10x, 100x, and so on.
So it's really embracing the separation of concerns between the domain expert who's really just trying to solve a problem, right, and the tuning expert who really knows how to get performance out of the architecture. If I'm doing data analytics, if I'm doing numerical analysis, statistics, that having a Python that's already plugged in to the Intel performance libraries. So you've encapsulated all that tuning expertise into the libraries. Is that the motivation?
That is the motivation, because the stock Pythons are leaving a lot of that performance on the table. So really, Parallel Studio, the primary goal is to make developers productive at what they do and extract all the information, all the latent goodness that is in our platforms and so on.
Okay, so let's talk about that a little more.
Sure.
Where's my automatic vectorizing and parallelizing compiler? Why won't the compiler do everything for me?
This has been the holy grail of programming since forever. And in retrospect, it always looks like the world was simpler and things used to be better. But if you talk to a practitioner of the time at any time, you find that it wasn't really that way. It just seems that way in retrospective. I don't know that we're ever going to get to a place where everything happens for you automatically. And the really encouraging thing for me is everybody realizes that today. So nobody's really waiting for that. You heard that much more often a decade ago than you hear it today. I think everybody realizes today that programmer has a lot of knowledge about what's happening in their application. And if they can simply get the programmer to tell you what's happening, it's much better, easier, faster, more productive, and reliable, rather than having a compiler automatically discover all that.
And so why do I need fancy tools, though? If print statements and internal timers are giving me the debugging and profiling information I need, why do I need a fancy tool?
Yeah, it's hard to figure out where to put all your print statements all the time, right? Experts, you could argue, can know that, but I'd argue back pretty strongly that you'd have to really be able to foretell a lot, because you have no idea. Software applications last multiple decades, so you can't predict what kind of architectures you're going to be running on, what kinds of issues you're going to run into. Also, people are putting software together from many sources, coming from different teams within their company. Sometimes you're licensing some software from other teams. You're using open source software and so on. And if there's a problem in any of those areas, it's impossible to predict where to put all your print statements as you're integrating all this software. So tools make it much easier to, and our processors have hooks built into them. The stack has lots of hooks built into it to let you understand what is happening.
And so how does Parallel Studio specifically help me focus my tuning effort on the places in my code that actually matter?
We've got a tool called Intel Advisor. Its primary purpose is to help you modernize your code. Focus your attention on areas where you're actually going to benefit. So it's really a design aid. You can think of it as a design aid giving you advice on what kind of performance you might be leaving on the table and how to go about achieving that. So a lot of the architects and so on use Advisor in their planning stages. Given my large application, where is it beneficial to go add vectorization? Where do I need to tune the memory and data structures? Where do I need to go add threading and so on? And really focus on analyzing that before you actually change your code, because the process of changing your code is pretty long and expensive, and you don't want to undertake that unless you understand what the benefit will be.
Now, there's a promising new feature in Parallel Studio called Application Performance Snapshot.
Yeah.
That seems to aggregate and summarize a large amount of performance data about an application.
Mm-hmm.
Is this a trend in tools right now, or at least a trend in Parallel Studio?
It is, and this goes back to capturing domain expertise, capturing the speed of computers to do the analysis for you automatically, and aggregate information for you. Architectures are complex at this point. No programmer is expected to understand everything that is going on in a system. So just being able to, at a very high level, glance at different areas of your application and of the system and decide where to focus your attention is the idea behind it. So for example, is the storage subsystem bottlenecking my application? Is the memory subsystem bottlenecking it? Or is the compute system bottlenecking it, at a very gross level? And then you can decide and take deeper tools and dive into them. And so that's the idea behind Application Performance Snapshot.
Okay, so Sanjeev, you've been developing tools now 30 plus years. Mm-hmm. What do you see as the next big trend in software analysis tools?
The architectural diversity is really driving the need for tools for people to be able to really utilize the full benefit of the architecture. In addition to that, the need for domain experts to really focus on their expert areas of expertise and let just the separation of concern notion that you talk about. Let the tools and let the people who understand math, for example, give you the math libraries or the data science libraries and so on. So I can focus on on my social science, for example. All of those things really point toward more and more separation of concern, more and more encapsulation of expertise into different packages and so on. And then the way people work together, working over the cloud, working from anywhere at any time, being able to easily deploy their software in containers in a cloud and so on. So this idea that, just like your email, you can access it from anywhere, from any device and so on. I expect we get to a place where I can start my compiles from anywhere. I can look at what is happening at my application from anywhere, whether it's my phone or my PC or my tablet and so on. So that's the path that we see in a long term, really. That's where I'd like to see the Intel Parallel Studio and the world of tools to evolve.
Thanks, Sanjeev, for sharing your insights today.
Thanks. Appreciate it.
I'm Henry Gabb with Tech-decoded. Please visit our website for more information about Intel programming tools for code modernization.